Hello everyone, welcome to the course of Data Analysis and Statistics using Python. In this course, we'll be learning towards the how we have to analyze the data, how you have to visualize the data, how you have to manipulate the data in a graphical way. After that, we'll be moving towards the statistics things. So first, we'll be seeing that the libraries and the packages, how we have to working with that to analyze this, to visualize it. So basically, we know about that Python doesn't support the array concept. So we are having a library called Numpy. With the help of Numpy, we can work with all the features of arrays, list, and basically we call as the alternative methods of list and array. And it's help you to do that to maintain the minimal memory, to do all the operations of mathematicals. Then you can work with your dimensional array 2D 3D. So those things, with the help of this we can work on with the numpy. Then we move to the pandas, where basically the pandas is used to analyze the data. We can do the stock prediction, advertising. With the help of pandas we'll do the advertising, analyzing. And in a neuroscience also we use a pandas. Take as a example where day-to-day life we are using YouTube, then Netflix and all. So how in recommendation we are getting, right? Once we watch a video, after that the same type of video recommendation we are getting. So there also we are using a pandas. So in a pandas we are learning that how we have to do those recommendation, how we are getting those recommendation, how we are once we watch it, how we are moving to see that the by default the recommendation comes to us. So this analyzing things we are learning in a pandas. There was a different libraries for the visualization like matplots, seaborn, pyplots. So with the help of all these libraries, will we visualize the thing in a graphical way. We'll do the graphical plotting like your with the help of box plot, pair plot. With that, we'll be working on the data. To with that we can plot the things in a graphical way, where will be more benefit way to understand, we to use that how the graphically the data look like. So those things with the help of matplot, seaborn, pyplot, we are learning on that. After all these libraries, we are moving towards the concept called statistic. In the statistics, we know that it helps in providing the data as well as the tool analysis for the real life data, and it will give you the powerful techniques there. With the help of all the techniques of statistics, we can analyze it, we can forecasting that particular things with the help of statistics in the using of your real-time data. It helps, and as well as the statistics helps to provide a better result with the use of real-time data. Means with the help of libraries, whatever we are doing that, when it comes to the statics, we are using all the plotting diagram or all the geographical plotting libraries to use that, we can give us to the better result to the real-time data set. In this, we are learning how we are giving the better result with the help of some powerful statistic techniques, and then we are giving all the quantitative data to use all this, and then we are moving to the result part. So these things we are doing in the statistic, and in this course, in all the section we are doing small project, mini project. At last we are doing one a major project, which is fully based on all the real time data. So last 3-4 session will be the most important session, because the reason behind that, in that particular session we'll be working on the major project. In that major project we'll be working on the real-time data, where we'll use the real-time data to analyze it, to predict it. Then we have to do the all the plotting, and it will be the graphical plotting. We can use pie plots, we can use map plots, c plot, and there are different plots diagram we are having. So all those used for all those plot diagram, we can visualize it, and we are giving a result on a proper way. So that is what the basically the analysis, data and project talk about. And in this we'll be learning all those things with the help of our real-time data. So this is what the data analysis statistic using Python course is worked for. Thank you guys. Hello everyone, welcome to Numpy course. Before jumping to the Numpy, we should know about some module package and should know about how to install an Anaconda Navigator, means the main software for to working with the Numpy. So you can observe that already I open an Anaconda Navigator. So we move to Google Chrome where we should search first to download the Anaconda Navigator. So Anaconda Navigator, into it. So the first link only you have to go with the first link where it will be a Anaconda Navigator or Anaconda documentations are there, and there is another one individual addition for Anaconda. We are moving to the Anaconda Navigator where you will get the link where we should download, and this one is a official document for the Anaconda Navigator. So suppose you want to take a help from to how to download, how to use it in a this thing, so you can take a guide because this is an official Anaconda Navigator documentation. You can go through with that to help on how to install it, how to work on that, what is the features are available. You can look over that for taking your reference. So move to installations. There is another one is individual edition. Move to individual edition for Anaconda. Yeah, so you can observe that the it shows your data science toolkits. Then it shows how we have to install for the Windows. So we'll go down, fully down. Yeah, when it comes to the down, you have options for the installer. First thing, remember that whenever you install or download, you have to download first. You should check your system and check with the configuration of your system. It should be a 64-bit or the 32 bits. So if your system configuration would be support the 64-bit, you should go with the 64-bit. Your if suppose your system was supported for the 32-bit, so you should go with the 32-bit. So as my system was supported to the 64-bit, I'm going with the 64-bit graphical installer. For me, it's already installed, but I click it for you people to understand how you should download. So you can observe in a downside, and here also they will give you the message. Thank you for downloading. So in downside, you can observe it's already start downloading. So as you know that I already downloaded, so I cancel this downloading part. So this is how you have to work on the Anaconda, how you have to download it. After this particular download, nothing you have to do, as we know that how you have to install a basic software. Open that particular software that's downloaded and just go with next option. Next, skip, and next. Then it's finished. When you finish it, yeah. After installation of Anaconda Navigator properly, how you have to open it, right? So in a search option, you just want to search it, Anaconda Navigator. You can observe here Anaconda Navigator is there, prompt is there, Jupyter Notebook, it shows spiders. So we are moving towards to the Anaconda Navigator, just open it or run as a administrator. That will be a more beautiful option to work on Anaconda Navigator. I already open it, so I'll not open now. So we'll move directly to that the page. When you open that page, this page will be open. So this is the page where we have to work. Here we have a different features available where home, environment, learning, community, and this is the main thing. This is a command prompt for the Anaconda cmd.exe prompt, then data load, then comes to your Jupyter Lab, Jupyter Notebook, PowerShell prompt. We have a Qt console also, and this will be work as a command prompt we call Qt console. So we can work on Qt console to handle all the command. To use our graphical, we use a Jupyter Notebook to work on particular graphical or our module, which we learn some to the Numpy, Pandas, Matplot. So we work on to Jupyter Notebook. Now move to Spider. It is also one features for your working on the front end part. If you want to connect with the front end to that particular things in a database, we use a spider, we use ticket enter libraries. So we'll learn one by one how we have to use a spider or in Sweet PyCharm. So already most of them we know about that. PyCharm is basically used to work on the Python. So we already have that option also here in a PyCharm to work on the Python properly. R Studio. For the data science, sometimes we use R features like R programming language. That is a different type of programming language, like how Python we are working. We are having a R Studio. We can work with the R itself. So mostly we'll start with the Jupyter Notebook. So now first we are moving to the environment to set up to how environment variables we can set up. We'll see in the next session. Thank you guys. So hello everyone, welcome to Numpy course. Before jumping to the Numpy, we should know about some modules and package. So in a previous session, we learned that how we have to install the Anaconda Navigator. Now we'll see how we have to move to the environments, how we have to install it, the package and module. So we already have some virtual environments which already there, so we can observe that like Anaconda projects, and then what we are using NumPy, Pandas, TensorFlow already in a predefined environment. It's Anaconda Navigator is providing us. So some of the environment already it is available here, so no need to install in that particular environment. But suppose you want to create a workplace, you can create that particular workplace here, and if you want to search that particular works it's there or not, you can search through the environment. So to creating a particular workplace to that, so we can go with the project name.env file. With the help of project name env file, we can create that particular thing. Now we'll install the package through the command prompt or cmd.exe prompt. So we launch that first. Now you can observe that particular screen. So yes. So first thing how we have to install is, so the easiest way how we have to install, we use things called pip install and then your package name. Package name. Enter. Yeah, so collecting the packages, because already already have that already packages, so it shows that. So now move to the first one. Suppose a NumPy, we know that is existing packages, but we try once. So pip install NumPy, install NumPy. Okay, so as we know that it's already existing package, so it shows that requirement already satisfied. So you already have the package. So to get that different type of package or module, we can just go with the Google Chrome and we just search that py yeah, so the Python package index. So there was a variety of packages you will get in the site. You can go with that. You can observe. We can take off help of that which packages you wanted. So different packages is available in this particular training. Packages are available in this particular way. So we can search the packages. You can use that particular packages. So suppose we are moving to take the random package called JSON. So just search Python package for JSON. Yeah. So you can get that. This is the packages already available in this. From here also you can take that particular library directly, pip install JSON library. You can copy this and then move to the Anaconda Navigator command prompt. The same thing, you just paste here. So you can observe that we paste it, run. So it will be installing, collecting the all file and install that particular library. So this is how, because it's already there in my system, so it's collecting. So same way you can install all your files and packages, because it's predefined already, those packages are available in my system, so it shows this. So you can, or else if you don't want to copy, if you know the particular package or module, so you can go with that also, like pip install JSON. Already satisfied. I told you like already we are having that package, so it shows already satisfied. So when you install the first time in your system, it will be installed in the same way. So this is how we have to install the packages or modules in a Anaconda Navigator. Hello everyone, welcome to the Numpy course. So Numpy is also known as a numerical Python, or it's a library which is used an alternative for your list than Python. So it is a Python library which is used to working with a list and array. So first thing, what do you mean by NumPy or why we call a numerical Python? So basically we call NumPy is also known as numerical Python. And here, if you observe, it's a Python library. It's a Python library. So Python library means there is a various type of libraries available or packages already there in a Python which we have to use it. So NumPy is one of that library. With the help of this, we can access or we can working with the features of list and arrays, which is not possible in Python. To use for those particular thing, we used a NumPy. Now, where or how we are using this particular NumPy? Before we'll be knowing that who developed this particular thing. So this library was developed by Jim Hookney. This library is developed by whom? This library is developed by Jim Hook. Hugunin. So this library was developed by Jim Home. So now we'll see some operations of NumPy or Python library NumPy. So there is a variety of operations are there. So we'll concentrate with some operations. Operations like whenever we worked on the NumPy library, we have to follow some operations like we are working with the mathematical operation. We are working with the logical operation. We are working with the transformation. Then we are moving to the SEEP manipulation. If you work with the SEEPs, we'll be working with the SEEP operations. Then there was a lots of linear algebra operation because we call as this is a linear algebra. The reason behind that because we call as these things are all a numerical Python, right? NumPy we call as a numerical Python. So whenever we call as a numerical Python, it means that it will support the mathematical, logical, shape, linear algebra. So with the help of this particular library, we can easily work with all the mathematics function what is already used. So this is the operations or use of your Python library. So it is also a replacement of a MATLAB. Let's see how it will be a replacement of MATLAB. Suppose this is one memory or Python memory. Python memory. Inside this, there is another libraries are there. So for now, please concentrate with the NumPy library. Different libraries like pandas. Then you have matplotlib. Then you have Skype. At last, we are having a NumPy. So it will be also a replacement of memory of your MATLAB. So before the NumPy library, we have to use all this matplot as a traditional way. But now to do the easiest way, we are directly working with the NumPy. Basically, this matplot was a replacement for your NumPy library as well as your Skype library and your matplotlib library. So basically, MATLAB of replacement for these three libraries. With the help of this, it will be working on the various platform, various advantage or various way. Like easily we can do all the array orientation computing. Easily we can find out the dimensional way. We can present the graphical way. All the mathematical operation we can perform with that. So now, after knowing all the features, all the key values, all the alternative about NumPy, the first thing comes to the mind, why we use the NumPy? We know the alternative, we all those things, but why? Why not the different thing? So the main thing there, NumPy will be provide you the array object. So that will be in a 50x faster than the traditional Python list. As I told you, NumPy is a alternative for your list array MATLAB. So why? What is the reason? We can do it all the operation with the list also. Just we want to design in that way that can support it. But when it comes to the memory, we need the things to be a more faster because we know that nowadays the faster things will be we working with that. We need to reduce the time and do it fast. So the main reason behind that, it will give you the 50x faster than your list and array. So that is the main reason behind that why we are using a numpy. And why numpy faster than list? That is the next question comes to the mind, like why it should be a faster than list? Why not the different libraries? Because it supports the both thing and it's a continuous place in a memory. When I am explaining you people the memory of that, so this is particular your memory, right? We call this is a memory. So whenever we use the memory these things to save it, by default it's stored the way the numpy values. This is the values. How we are saving the values inside that way, it gives us the memory should be work faster. Memory should be work faster. So that's the reason we are using this. And in a CPU architecture, the optimized time, suppose this is your CPU memory, optimized time will be less because every CPU will work with the optimized times, right? So optimized time will be less. So that's the reason most of the time we are using NumPy except with the other things in a Python. Hello everyone, welcome to NumPy course. So today we'll be learning about how the environment will work in a NumPy as well as how we have to install NumPy in Anaconda Navigator and how we have to import it in a Jupyter notebook. So let's start on that. Yeah, now comes to environment. We are having a step by step. First, how we have to install this particular thing. So this is the basic way or the basic way to install. We use a line or code is pip install numpy. So basically pip is nothing but your package installer. We call this is your package installer. Pip is known as package installer. So whenever you want to install a package, we have to use a keyword called pip, and then we have to move towards with the install, pip install, and then here a package name. Which package you want to install it, that particular name you have to install in a where in a Qt console or a command prompt, CMD, in a command prompt. So this is the one way to install, and if suppose your system was not supported a NumPy, because sometime when you download a Anaconda Navigator, by default NumPy is installed. So that particular time no need to install that NumPy. You can go with importing directly, we can use it. But suppose the setup is not there, or when you install by mistake because of some reason the setup is cracked or you install a cracked version. In that particular time you have another option called pip setup.py install. You can use it in a CMD prompt the same way to install the setup in a proper way. So this is the another way to install a NumPy. So now move to the importing. Once we install it, we have to move to the importing. So there is a two way to import it the same way. Both are 99.99% is same, just we are using one importing time alias name and one just normally imported. So how we have to import, just we are using a keyword called import and then which package name we are importing, NumPy. So this is how, this is just a package name. So we used a package name, your importing is done and that will be in a Jupyter notebook. Now there is another way called import NumPy as NP. NP is nothing but we call as a alias name for NumPy. Like in our house, what happened? We are having a big name, school name or original name. In Aadhaar card, we are having one big name. So in a home, but no one call us with that particular name, right? We are calling as a different nickname. So alias name, nothing but just like a nickname. So always to use NumPy everywhere to work on that, it's too difficult, right? So to reduce this difficultness, we used our alias name for that particular type. And this alias name we are using NP. It's not compulsory you have to use NP, right? You can use any alias name there and just you have to remember that alias name. But most of the time we are using NP because it's a closer to NumPy words. That's the reason we are putting NP. But remember, there is no compulsory. You can use AB, you can use XY, you can use X. But just depend upon your comfortableness, depend upon your uses. You have to choose your alias and you have to remember till last. So that's the reason we are using this particular things the way how we have to import. This is how we have to install the NumPy, how we have to import the NumPy. Till now, I think you will be clear with the theoretical aspect of your NumPy. Now we are jump to a Jupyter notebook directly to understand the practical way or practically how we have to install as well as how we have to import. So let's move to that. So first thing, when you come to the Anaconda Navigator, you have to check NumPy is installed or not. By default, in Anaconda Navigator, NumPy library is installed properly. But if it is not, how you have to install, you have to go to the command prompt, cmd.prompt, launch that particular part. Here, you just move with that same keyword call to install pip which call as a package installer, pip install, and which package name you have to give a package name here. So pip install, you can go with the package name or we directly go with the NumPy. So let's see with the package name. You can go with the package name first because we have to give the package name up. You have to install those package name collectively, then move to NumPy because we know that it's just to show you where the package name, how we have to use it. Now move to pip install NumPy. If you observe here, requirement already satisfied because in an Anaconda Navigator in my system properly NumPy was installed. This is not a crack version. So when you download it, check this particular thing once. If not, you have to install it in a two-way once. You can go with a pip install NumPy or pip setup.py, then you have to go with the packaging. So this is the two way you can install that particular thing. Okay. Then we move to the Jupyter notebook because now we have to start with our. Now we'll start with the Jupyter notebook. You can observe that already it's open. So how we have to go inside new, then Python 3. When you come inside, the new notebook will be open in front of you. You can observe it. This is a notebook from where you have to work on that. So how you have to import this particular part. So im, import numpy as np. Run this. See, it's run properly. Then comes to just check. For a small code, I'll show you to check that, like, is it working or not, the numpy thing. So suppose I just want to print some values. I'll go with any variable name. Then we'll create the array. NP, because we have to use numpy alias name to use the numpy things or numpy variables. So np dot array. Then we'll create this. Is 1, comma 4 or 2, comma the random values. I'm taking just a random values. So this will be one particular set. Brackets. Don't forget to give a bracket properly. You should give a brackets properly. Run. Then print s. You can observe that we are printing a number as a list way. So list 1 comma 2, list 4 comma 7, list okay 76.7. I'm giving with the floats value 76 comma 67. Run once. Here print once. Yes. So this is how you have to work on the numpy things in your Jupyter notebook. So this is the way of using this. Before that, when we have a list and numpy, it comes to the single line. So that is the way to list to print, but we want a way in an array to print. So this is the way how you have to print an array using a numpy. Hello everyone, welcome to Numpy course. So today we'll be learning about the ND array object in Numpy. So basically this ND array object is called as n-dimensional array. Basically, it's a usually fixed size. So remember that whenever we use the NT array object or n-dimensional array object, the size will be always fixed size. And we call it a multi-dimensional container of an item of same size and type. One more thing, size and type will be always there. Like we are having a size and type for your ND array. The number of dimensional and your items, whatever we are using, it should be saved, which will be a tuple or non-negative integer. We can use all the data type using a ND array object. And if you using this, your buffering or your any array interface, it will be less. How it will be? If you observe the diagram here, we are having a data type. Which type of data types? We are having a varieties of data types. In the further session, we're learning deeply about data types. For now, suppose it's a integer type, and here this array scalar means your head part of the array. Here we have to go with the head, whatever the header values are there in array. Now one more header is also here because it's linked with your data types. Your data type will be linked with the head, and this is your values. All the array values will be here. The values means n-dimensional, little n number of values will be here. It should be start from 1, 2, 3, 4, 5, 6 till n dimensional. So values will be here 1, 2, 3, 4, continue 5, 6, 7, 8, continue. Here what happened, they will choose one scalar value, and that scalar value we put it and we give you the name as a head, and that will be the integer type what we use here. In there was a variety of data types are there. So which data types it will be, that data type of n-dimensional array, it will be created. So this is how our n-dimensional array is basically used for. So for that also n-dimensional array we are using a Numpy library. There is no different libraries and all. We used a Numpy library for that. With that we are having some parameters also. So take a look on the parameters. We're having some parameters like we have to follow with the object parameters, then we are follow with the d type parameters, then we are having a copy parameters, order, then you have and daemon. So those are some parameters, etc. So those parameters we have to follow. So object means when we are having a particular values we have to take the object to call that. D types means which type of data types are there. Copy, if you want to copy this particular array you can copy that. Order and NNV. So this is how an ND array object is basically used for. I hope in a theoretical aspect you are clear with the ND array object. Now we jump to Jupyter Notebook to see how we are working. So now we'll start with directly with the Jupyter Notebook. So new Python 3. So our new notebook will be open in this particular. You see, we can save directly there to the in a new folder, or if you want to save directly in a desktop, that is fully your wish. You can save directly a file. After that, save as, you can go with that, and you can give the particular path here, and then you can save it. So this is the one way to save the particular path or particular notebook in your system. So now we'll move to see how we have to work on the ND array. So the first example we'll see the how we have to going with the first dimensional array. So before that we have to import the NumPy. That will be the compulsory thing whenever we are working with NumPy. Importing will be compulsory for each and every new notebook. So import NumPy as np run. So there was lots of shortcuts are there. See, anyhow you're getting an option here run. You can go with that, you can run, or you can use the shortcuts also like control enter for the run. So those are small shortcut for your Jupyter notebook. If you want to go with that, you can go with the Google Chrome. You can search all the shortcuts how you have to use the Jupyter notebook. That is more helpful for you to use the Jupyter notebook easily. So now move to this. So we'll create a normal array first, or we'll be moving toward the first one dimensional array. So we'll go with first one dimensional array. So I just give it a comment on that. For using a comment, you can use a hash to use a comment. Now to create, we have to give a name to create the array. Suppose array1 equals to np, because the alias name of numpy is np, so we are going moving to np dot array to create the particular array. Bracket, first bracket, second bracket, suppose 20, 40, 50, the randoms values I get, and then we want to print it. Print array. You can observe this first the normal dimensional array is created properly. So this is the only the particular one values I'm giving. Move to some different value to give how we have to. Importing already done. We are moving to create one more array. Array2. I'm giving the name of the variable name of the array is array2. np dot array. Then suppose 1 comma 2 in a one set. See, remember that whenever it will be a one set, you have to continue with this, comma 2 comma 3 comma 4 comma 5 4 comma 5, print array2. Here we miss one bracket, so close that bracket because it will be in a one set. So that's why we have to use a square bracket to give this particular array. Run this. you can get the one-dimensional array. Now move to the minimum dimensional. When we have a one dimension, we work on this. When you have a minimum dimensional, how we have to work on this? So go with the minimum dimension, minimum dimensions. For that, importing already there, so we'll move to the another array. Suppose array 3, the variable name, np dot array bracket start symbol, then 1 comma 4 comma the random value 7 comma 9 comma 5 comma 6. So I'm giving some random values for this minimum and D and min. So this is for your minimum dimension. We have to take with the minimum dimensional array. So we use a ND min equals to suppose 2, and then just print that particular array. Print of array 3. Run this, we got a particular minimum dimensional array, or we call as a ND array. So same way we are having a one more parameter, that is a D type parameter. How we are working with the D type parameter? Suppose go with the D type parameter. Here same way you have to create one more array. So array 4 equals to np dot array, and you have to create some values, suppose 20 comma 50. So two values, I'm taking two values, then comma d type keyword for the d type. And then if you want to go with any complex number or your linear numbers, so that's depend upon you what you want to. Suppose I'm taking a complex, so complex, and then you're moving to print this particular thing. Print array 4. Right. So if you observe that it's printed in a which way? Complex number way, because all the mathematical operation is supported by your Numpy. So in that way it will be printed, it is supported and printed with that particular way. Except this, we can go with some another types also, we call as your shape or your T type already done. We can go with a shape operator also. That's depend upon the things how we are using with the ND array. So this is the way of n-dimensional array to use in a NumPy. Hello everyone, welcome to NumPy course. Today we'll be learning about the data types in using NumPy. So we'll start on the first data type called bool. Bool is nothing but your Boolean data types. Here what happened, whenever we are using a Boolean data types, it's stored always a byte. So remember that it's store a byte. Either it will be a true or false. This is the use of your Boolean library. Now next one is your int. Int is nothing but your default integer type. So it's just support a integer values. So this library supports an integer value. You can go with a int. Then we are having a int c, int p, int 8. Then it continue with the 16. Like bytes or bits values. So go with the start with the 18, int 19, int 16. Then you are having a int 32, int 64. So continue. So this is what our integer data types used for. Whatever the integer value, if you want to store like 10, 20, 30, that particular time we are using a int data types. Now move to int c. Just now I told int c also the same way we are using for the integer value. We are having another data types called unit 8. Basically this unit 8 is a unsigned int. This is also a one type of integer data type, but it is a unsigned integer. Unsigned integer. So now the one thing comes to our mind, we are having an integer data type once. Why we are having a different ways of our integer data type or different name of that. So this they are having a range on that, because whenever we are using any integer values, different integer keywords, different integer bytes storing a different range on that. So take an example, like whenever we are start with your init int, that time it store either in 64 or in 32. That is a by default values. Here I'm talking about int 1. It will be store always a by default. Either it will be storing your particular in 64, or either it will be store your in 32. Now move to when comes to the int c, it will store normally in 32 or 64. For 8 bits, it comes to your minus 122, 127, it's continue. Same way, unsigned integer, whenever we use it, it store a value called 0 to 255. If you remember, that range is similar or same, that particular range is same as a character range. Whenever we use a character data types, the character data type range is 0 to 255. Here, when we use a unsigned integer, that is unit 8, we use unsigned integer also, it will be stored 0 to 255. But when it comes to unit 16, it also has a variation. When it comes to unit 16, it start with 0 to 65535, and it continue till 64, and range will be varied. So depend upon our requirement, our client's requirement, we have to choose the data type properly. So data type also play a important role in our coding or in our programming, because with the help of data types only we can understand which type of data you have to use. Take as example, you want to store a value is 257. If you use unit 8, so it's not possible to store this particular, then we have to move to unit 16. So that is the use of this particular use of data types. Now comes to floats. We know that this is for the floating value. We are when we are using to store 80.64 or points values, we are using a float data type. For floats also, we are having with the float 16, float 32, 64, continue with the range. Comes to complex, whenever we want to use to store a complex values, like your 3 plus 2i means real and imaginary components. Remember, complex means this is a combination of real data types or real values and your imaginary IMA. So now I hope you are clear with the theoretical aspect of your data types. Now we directly jump to the Jupyter notebook to see how the different data types used in practical way. So let's start. So we are in a Jupyter notebook. We'll move to new Python, the new Jupyter notebook. Now we'll start with the data types to use. So now we'll import first. Import numpy as np, and then we are moving to create a variable to check that which data types we want to use it. So suppose var1 variable 1 equals to np, the alias name of numpy, d type. Have to check the type, so i4, and then just print var a variable 1, print. So you can observe that we're using integer 32. So this is how we can check the particular. So now we'll see with the first one, the bull one, how we have to use it. So already we imported, so we start with a variable name. So suppose variable name we're using var. You can use any variable name. Then moving to np, alias name dot array. After that, we'll be continuing with to create a values. Suppose 1 comma 2 comma 3. I'm just giving a random values to create that. Then we have to create another variable to store the boolean one, because we have to check with that boolean data type. So var2, suppose already we use var1 in the same notebook, so we're moving to var2 equals to which one we have to change, the var1 to var dot as type, that is for your type, which type you have to go into, that is bool. So boolean type, and then we have to print a bool. So print var2, print var. So both we are printing. So this is how, and when you are printing, the another one can check with the d type also. If you want to check with the d types, you can check with the d types, that is var2 dot d type. So here what happened, first we are going with to create a normal array, then we are going with the boolean data type. So we created another variable name, that is var2, and then moving towards to the name of the array, which one we create and store the variable var. So you have to go with that. As type, for this, which data type you want to use it, the data type is bool. Then we are moving to print var2, we are printing directly the var2, and then we are trying to print it with a d type. So we'll run this. So you will get that d type means which type, which data type. Before that also we use a d type. So that time is integer 32. It shows because we pass i4. Here we pass a bool values true, true, true. So that's why it shows a bool. Now, when we pass the values, here always it's true. Take a copy of this. Let's see with the, because boolean will be always true and false. So this is true. Suppose we are putting zeros here, 0, and we are putting 0 here as well. We are putting 0 here as well. So run this, you will get the false one. So 0 and 1 and another value, it will give you the true, and whenever we use as 0, it will give you the boolean as a false. So boolean will take true and false together. So this is how a boolean data types is work, and how we have to use a boolean data types. Other data types we'll see in the next session. Hello everyone, welcome to Numpy course. So in a previous session, we worked with the data types. We saw that how the Boolean data types work. So we'll continue from there. Before we move to the another data types, we should know about that whatever data types we used it follows the three principles. So those three principles are type, size, and order. So it will be depend upon the data type, like whatever the data should be, to which type, and those already we discussed, that is your integer or boolean type or your characters. Then move to the size. What is the size of the data types? Means values. It should be a 10 array size or 20. We can see with the size of that, and order, which order we need to use that particular data type. So those we have to follow this three principle whenever we use a data object. So let's move to that where we stopped in a previous session. Now we'll be moving towards in a Jupyter notebook to see that how the integer data, float data, complex data will work. Before that, in a previous session, we already look over the Boolean data types, how it's work. So already we import the NumPy, so no need to import now. We'll continue with to see that how the integer data type will be work. So first we need a variable. So we'll go with any variable name, suppose array1 equals to np dot array, and then we have to create a small array. So suppose your 10, 30, 56, 40. Yeah, so we'll create one array and then d type. So whenever we created this particular array, we are moving to the d types of i4, because we want to say that i4 means it should be your integer 32. So we use here for the i4, so comma d type equals to i4. So this is done with the np.array. Then we have to print, and we check that how it will be work. So move to print. First we want to print the array, so or variable, the variable name, and then we want to print array name with the d type, means which type you want to see that particular thing also. So now this will be the output. First one, we print the normal variable. So it shows that whatever the array inside the array variable, whatever values are there, it gives that. And after that, we are having with the int one, because we put here the data type is I4. So that particular data type, it shows that. So this is how we have to work with the integer data type. Before moving to see that how the float will be worked with the help of some keywords, we check out that which keyword and which variable name we use for all the data type. We use some numpy character in data type, like whenever we want to use an integer, we can use, except an integer or in 34, we can use directly I. So you can observe that whenever we want to check that, we put I4, it shows integer 32. So we use a character is I. Then for the boolean, we use B. Then for the unsigned integer, we use U. Then comes to float for F, and complex for S, and string for S. So this is all the character integer what we use for this particular things whenever you want to use the character directly. So for integer, we can use I4, for integer 32. For boolean, we can go with the B. Unsigned integer, we have to go with the U4, U3, and depend upon that the values. Then same with the F, then complex for C, and the string for S. So it's your wish, you can go with directly with the data type's name or with the character. So let's see that how it will be working up practically. Let's move to directly in a Jupyter notebook. Yeah, we are in a Jupyter notebook now. So we'll see that how we'll use the characters, data types character now. So already we imported that, we just run once. So already imported. Now move to here, just to create one variable, suppose VRR, variable name, then np dot array to create. We can take the same values, what values you are taking here. We're just to see that how the character names are using now. So that then in this we created those particular thing now for the new variable. So new VRR, I just give the variable name new variable, and the old variable name we have to go with that VRR dot AS type. Now you have to give the type. If you remember when you work with the boolean, in this particular we put the bool. Here we're not giving the int, we except int we are using directly with just the character name, that is I, for the integer. Now print new variable, and then we'll print the with the d type also we have to print that particular one also, the normal variable. Print new VRR variable dot d type. So this is how we have to work with the normal values. You can observe that it's print the values, then it print the int 32. Now, suppose we are taking the same values, I just copy paste that value, and we are taking in this time the floating points, not a normal values. We are taking the floats values. So 10 comma 56 or 50, then 30 comma 14, 28 comma 36, 56 dot 57, 40 dot. I'm just taking random values to give a floats value 68. So now another thing it will be same. We are taking an integer, but we are taking a value in a compile term with the floating points. So when you run this, you can observe that you will get the things here in that way, where in 32, 10, 30, 28, 56, 48, 62 means we are taking a float value, but when we pass the type is integer, it will be taking only the integer value. Whatever the floating points are there, it will not taken as an output. So this is how we have to use the character things. Let's see one more example. When we take except I, we are taking directly the integer. So there is another way also. So I'm taking the same code here, paste it. In this, we can go with int. So you can observe that here also it's take the same value 10, 30, because that is fully your wish. you can go with the data type name or you can go with the data type character. So this one will be the character, this one will be your data type. So this is how you have to use a integer data type in that. Now we can see that how the other data types, like when you want to use the float, in this particular way we can go with the floats values. Suppose take this one, paste it. Suppose you want to go with the float. Yeah, so this is how we are using a float. Same way, if you want to use for the character name, take this, paste it. Here we pass F, and it will be in a single quote. That you remember, it should be in a single quote. Yeah, so this is how you have to use your data type in Numpy. As well as if you don't want to use data type name directly, you can use a character name in that. Hello everyone, welcome to the Numpy course. So this session will be learning about the array attributes in Numpy. So basically array attributes are essential to find out the shapes, your dimension of that array, size of that array. With the help of array attributes, we can connect with the ND array object which we already learned in our previous lessons. So with that we can connect with the ND array object of Numpy, and we can do all the operation with the help of attributes. So there is a varieties of array attributes present in a Numpy. Like we are having the first one is ND array dot and dim. So in this we can go with the n-dimensional array. For that particular time we use this particular attributes that come to the shape. With the help of shape attributes, you can give your size or shape to the array, like 2D array, or if you are using a multi-dimensional array. So if you want to give the size on that, like shape on that, like two values you want in that particular shape, 2 cross 3, 3 cross 3 matrix. So in that particular time we use a shape. Now come to the size. When you are giving a size, it's compulsory you have to give a size. Your matrix like 2 cross 3, 2 cross 2 matrix, or 3 cross 3, that particular time the size is nothing but we have to give a array size on that, which array size it follows with the dimensional D type. So what type it is, like which data types it is, so we can use this data type to check that is it integer or is it float or it comes to the character or string and or complex. So that follows with the D type. Now comes to your item size. With the help of this, whatever the item you are using, it should be integer, float. What is the size of that particular item? Suppose you are using int and any variable. So what is the value of that particular thing and what is the size of that? So this is what our array attributes basically used for. So I hope you're clear with the theoretical way to understand the array attributes. Now we jump to the Jupyter notebook to learn that how we have to work on the practically the array attributes in Numpy. So we'll start with the importing first. So import Numpy as NP, and then we are moving to create a normal array. So a equals to np dot array, and then passing the values. So 1 comma 2 comma 3 comma 4 5 6 7 8 9. One set is done. Then move to the another values. Suppose 11 12 13 14 15 16 17 18 19. Second one is done. Now move to taking one more. 21 22 23 24 25 26 27 28 29. So our array is done. Now we just print this particular array. Print A. Yeah, you can observe that it's properly. Now we'll create one more, the small one, to see that normal creation, and we'll see that how the shape operation goes. So take the variable name, suppose VRR or var variable equals to, then we create the np dot array and the values. So suppose 1 comma 2 comma 3 comma 4 comma, comma, and then one more, suppose 11, comma 12, comma 13, comma 14. So done. Then print var, so it will be inside the bracket. Yeah. So print var. So now we'll see the shape of that. Here we normally take the things. So I just take the same variable here, paste it. Now if we check the shape of that particular array, how we have to do, just give the variable name in a print dot operator, and then your attributes, that is shape, shape. After this we'll see the item size, how we have to use the item size. So already we imported, we move to the variable creation, suppose x equals to then np dot array, and we just create one values 1 2 3 23 4 5, some random values, and then comma d type equals to np dot float 32. You can use 32 64, depends upon you, you can use that. So float 32, and then you have to print the variable name x dot item size. Item size, what is the size of this particular item? X dot operator, item size. So you can get to know that what is the size of item, that is 4. So we'll see one more. So we can copy this, we just paste this particular thing. We can go with float 8. So you'll get a error because numpy has no attribute of floating. So check with 64 also. Yes, we got 8. Why? Because it's dependent upon how you're taking the float. So when you are going with the 8, NumPy doesn't support float 8. It starts from only it's 16, 32, 64. So when it comes to 64, it shows that 8, because we have to see that what is the size of that. It's not means how many values are there. It's depend upon the size, what you used it. For that particular, it gives the values on the size of your floats value. So we'll see one more example for attribute. Suppose we'll go with a variable name var1 equals to np dot arrange, arange, is one keyword to arranging the things 24. Then we move to your var1 dot ending. This is for your, when you are working with the n-dimensional, 3-dimensional, we use this attribute. So move to see that particular thing with the shape, print var1 dot shape. You can observe that it shows 24 comma. So this is how we are working with the NumPy attribute in Jupyter Notebook or in Python. Hello everyone. Welcome to NumPy course. So this session we'll be learning that how we have to create an array, how we have to use that, how we have to manipulate in a different way. Let's start on that. So now already we are in a Jupyter notebook, in a new notebook. I'm taking a new notebook. Just first we have to import a NumPy. Import NumPy as MP. So already we imported. Now we create a basic array first. So go with a variable name var equals to np dot array, and then we are giving the values. So suppose 1 comma 2 comma 3. So array is created. Now we want to print this particular array. Print var. So the normal array is created. Now we'll start with the empty. When we move to the empty array, how we have to use the empty features in an array creation. So the next one will be seeing the features of empty. So for that we need one more variable to create, or we can use the same variable. So I'm creating the new variable. I'll not disturb with the old variable, so that because of that particular reason I go ahead with a new variable. So var t np dot empty and then the values, whatever the values you want to give, suppose 12 comma 56, and then comma using a d type, which is already we know about that how we have to use the d type. So data type for that, which data types, d type equals to integer. In this you can go with integer, or you can use the keywords what we done with the previous session, we learned with the previous session. So int comma will be comma here. Now we have to print this particular thing. Print var 2. Now, if you observe that how much we are giving 12 and 56, 12 and 56. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 rows, 12 and 56. Here 56 rows, 12 columns. So it will be like that, rows and column. Taking with the rows and column, it gives all the empty. Empty means what? The null value. So that we are using empty in this particular way. So this is how we are using empty in a array creation. Now we are having a zeros one. So let's see that how we have to use zeros one one. So suppose we are taking the same code and here we are moving towards this, and except this one we're using another keyword called once. Run. So you can observe that whenever you use a once keyword, see different features are there, different keywords are there to creating an array. So in a starting what we done, we just create a basic array, then we move to creating the empty array when nothing is there. Here we are creating with a once. So whatever the rows column values we provided all over the once. So now we'll be going with the zeros also. Here what happened, we use a 1, taken this, just paste here, and in this particular way I use zeros. Zeros. So when you run that, your all the rows column will be 0. So this is the basics operations, like to use the array creation on that. So let's do some modification. Let's do, or let's play with some zeros one. So do some example. Let's go with that. So suppose we are taking one variable that is v1. You can take any variable name. So v1, and then we are going with np dot zeros and giving the one parameter. I'm just giving one parameter here. Print v1. So what happened? All the 5 values will be zeros because I'm giving a one rows and one. It's depend upon you what you want to give in that particular time. In the same way, try to go with the in a different things, and with the data type d type, how we can go with the integer in 34. Let's see one example with that. So go with the another variable v2 np dot zeros. Here we have to create it giving the values here. So you can give 2 comma 2, you can give 3 comma 3. It's depend upon you what you want to give. Suppose I'm giving 2 comma 2 values. The matrix you can choose it. Now d type equals to, you can give directly the one value, or because you are using 2 comma 2, you have to go with that particular way. So x, but any value we can go with a comma i4 for in 32, and then comma one more y comma i4. So that's fully your choice what you give the values. So a b also you can get xy. That's your choice what you want to prefer to working on this. And then print, you have to print that particular values. Yeah, so we got this particular output because we choose 2 cross true. So we got this particular output. If you go with 3 cross 3, you will get the 3 cross 3 values. So the same way, we just go with the ones also. Take copy on this, move to this. Here we just use except zeros, we use a ones. Ones of 5. We can get the output in a 1. The same thing, the same operation, we can work with the ones. Continue with this and change the keyword zeros to ones. ONES ones and run. So this is how we are doing that. There is one more, that is your empty. Empty means everything will be empty. So this is how we are working with the array creations. So we'll do some mathematic operation using zeros and 1. Let's see how we have to do. So for that also we have to create two array to do the mathematic operation like addition, subtraction. So suppose v1 or variable 1 equals to np dot ones, np dot ones 2 comma 2, or just giving, I'm just giving one values because we just want to add that particular things, or we can go with 3 cross 3 also. That's our choice. So already we saw that 2 cross 2. So now we move to 3 cross 3 to understand how 3 cross 3 will be work. So 3 comma 3. Yeah. So var1, we just print this, print var1, just to create all the ones in that. So we are creating this particular thing. It's done. Now the var2 will store some values of 3 cross 3 array. Then we can easily add that, and we can go with ones also. We'll see the both operation. That will be more comfortable to understand how the array creation will be work, or how the array will manipulates and work. So suppose var2 equals to np dot ones of 3 comma 3, 3 comma 3, double bracket, then print var2. Yeah, both variable is created. So now we just want to see that how it's created and just want to print it those things. So we can store those addition in another variable. We can do the print operation also. var1 plus var2. So you can observe that it's do the addition of all ones. The same way we are doing with the zeros. So taking this, paste it, just change ones to zeros, and the another variable name, copy, paste it here and change with zeros. And then we have to do the addition operation. You can use any mathematical operation in this particular. It's not compulsory you have to go with addition. You can go with subtraction, you can go with multiplication, division. It's your wish, no problem for that. So you can get that. The ones also, zeros also, we can do that. So suppose we are taking one variable with the ones, taking this, the first one, and move to down. Yes. Another variable, we are giving some values. vr2 equals to np dot, we already use arrange function, create function. We'll go with arrange, np dot arrange, arrange of 9 dot reshape 3 comma 3. So we are just trying to reshape that, and then we just print. So when we do the reshape and arrange, we got this output. By default it's 0 1 2 3 4 5 6 7 8. So by default value is there. We just want to add variable 1 and variable 2. Means var1 is storing the ones values in all 3 cross 3 matrix, and var2 will hold the by default 9 values in 3 cross 3 matrix. So print var1 plus var2. So this is how you have to working with your array operations or working with the array creation.